Welcome to Spring LIB.
So this question introduces a very important scientific method that is very essential for doing physics, especially for doing physics researchers. And this is called dimensional analysis. So what we do in dimensional analysis is that here we want to know what is the relationship of the speed of waves in the ocean, and how does this depend on other quantities. So we will guess that this is the speed of waves on the surface of ocean, and we might guess that it depends on the gravity, G. It depends in some way to the depth of the water, H, and probably also the wavelength, lambda. And we're doing this just by thinking about it and by trying to picking up numbers according to our intuition. And there might be some constant in front of it. And these, it could be square, it could be cube, so they will have their own power. I would just call them alpha, beta, gamma, because they are unknown. So from here, we will proceed because we know the unit of each of them. For V, the unit velocity is meters per second. C is just a dimensionless constant. G, this is the gravitational acceleration, is meter per second squared, to the alpha. H, the height, is meter. And lambda is also meter. So here we have a tiny bit of difficulty already, you can see, because both the height h and lambda have the unit meter. That means that using dimensional analysis, beta and gamma, we cannot distinguish between beta and gamma because they both have the unit of meter. So what can we do? Now the question made it easier for us because the question made two assumptions. It says that in deep water, we can assume that the water deep down below the surface water will not affect the surface motion. So for deep water, we can assume that V is independent of H. Or in other words, beta equals 0. And in shallow water, V is experimentally found to be independent of the wavelengths. So gamma equals 0. So this helps us break the teaching to values, because now we only have one quantity with the unit of meter. And beta per second equals m per second squared times meter gamma. Okay, and now we can finally start to do the actual dimensional analysis. So if we expand the right hand side, this is meter alpha plus beta divided by second of 2 alpha. And the left hand side and right hand side has to match. So this gives us this here. So this gives us the relationship that alpha plus beta equals 1 and 2 alpha also equals 1. And this tells us alpha equals beta equals 1/2. So if we put this back here, we get V equals some constants, we call it K, and square root of G lambda. And same thing here. And here we will get equals gamma equals 1/2. So here we will have V equals A square root of G times H. So according to dimensional analysis, we get this relationship for deep water and this relationship for shallow water.